Good morning, one and all dignitaries present here. Good morning to our keynote speaker. I extend my heartiest welcome on behalf of Department of Commerce and Center of Continuing Education, Kurukshetra University, Kurukshetra, to our keynote speaker, Dr. Shailesh Kaushal. And it is my immense pleasure to introduce you, sir. Dr. Kaushal is Assistant Professor in Department of Business Administration, University of Lucknow. He has been invited more than 300 times as a resource person and delivered lecture on research methodology across the country. He has published more than 60 research papers in national as well as international journals. His area of specialization is marketing management, statistics, research, and research methodology. He is highly proficient in the softwares like SPSS, MOS, Macros, Smart PLS, eViews, and R. We are very keen to learn from such a knowledgeable person like you, sir. I welcome you again from the core of my heart. Now, over to you, sir.
Good morning to all. Can you see this slide? Is it visible?
Yes, sir. Yes, sir. It's visible.
Measurement and scaling.
Yes, sir.
Okay.
Yes,
Yes,
sir,
sir.
it is
Okay.
visible.
Okay. Thank you. Okay. Good morning to all. Today I'm going to discuss exploratory factor analysis. Exploratory factor analysis, basically it is the multivariate techniques. There are three types of technique. One is univariate technique, bivariate technique, and multivariate techniques. Okay, so before starting the exploratory factor analysis, we should understand the level of measurement, how to collect data for the exploratory factor analysis. So what type of data we should conduct or apply for the exploratory factor analysis. Okay, so in a social science research, we use four types of level of measurement. One is nominal scale questions, ordinal scale, interval scale, and ratio scale. Okay, so in a social science research, we can prepare our question either in nominal scale, ordinal scale, or interval scale, and we use the term the nominal and interval. It's a non-metric data, or other name is the categorical data. So in most of the books or journals, you find the two terms, non-metric or metric data. So categorical or continuous data, categorical or continuous. So the data, another interval scale question or ratio scale question, it is known as metric or continuous data. So throughout the lecture, I will use the two terms, non-metric data and metric data, or categorical or continuous. If I am talking about non-metric, it means I am talking about nominal scale question or ordinal. If I am talking about the metric, it means my question would be either interval scale or ratio scale. Okay, so first of all, before the applying any statistical tools and technique, we should understand the what is metric or non-metric data, because in a quantitative data analysis we have large number of statistical tools and technique to analyze our data, but every statistical tool and technique has its own assumptions. It means if we want to apply the one sample t-test, it has some prerequisite that our data should be metric form. Okay, if we want to apply one sample Wilcox-Cohen rank sign test, it means our data should be in an ordinal form. So first of all, we should have idea about the types of variables like nominal variable or nominal scale data. So nominal means we can prepare our question in a nominal scale. So there are four ways to prepare our question. We can prepare our question in nominal scale, ordinal scale, interval scale, and ratio scale. Okay. So in a nominal variable, basically there are two or more categories. So in a like male or female, and whether someone is science background, commerce background, or an arts background. So how to prepare our question in a nominal scale? So nominal scale, we can prepare our question, what is your education background? So all the options are mutually exclusive. Either you belong to science background, commerce background, or arts background. So you have to tick only one option. Okay, all the options are mutually exclusive. It means if your graduation in science, then you cannot tick commerce or arts. Now the statistics used for this type of questions, like equal or does not equal. If I'm talking about in my class, the students belong to science background, commerce background, and arts background. So number of students may be equal, means the class of 90 students. So there may be two possibility. The each stream students equal 30, 30, 30, or does not equal. Means 40 students science, 20 students belong to commerce, and 30 students belong to the arts. So statistics we can use only equal and does not equal. Then mod, we can present our data in a percentage, like this nominal scale question, we cannot take mean or median. We simply present our data in the bar chart or pie chart. So like there are three uh, types of data. One is 40 means students. We can present our data in a frequency. The science students 40, and the commerce students 20, and the third, the arts students, the number of the 30. Okay, so this is, we can present our data either actual frequency or we can convert into the percentage. And the statistics we can use for this type of data, chi-square test. So if we are using two variable in a nominal scale, then we can use chi-square test. So then the second question we can prepare, that is the ordinal variable. In an ordinal variable, the same as nominal variable, but categories have a logical order. Like customers are very satisfied. Here there are five options: very satisfied, satisfied, neutral, dissatisfied, or very dissatisfied. Now the example of ordinal variable and how to prepare our question for ordinal scale. So it's just a simply a statement, like I would recommend this product to my friends, and there are five options. One is strongly disagree, disagree, neutral, agree, or strongly agree. It's a 5 point scale. We can prepare in a 7 point, 9 point, or 11 point also. So here the it's a Likert scale. It's a purely ordinal or theoretically ordinal scale question, but sometimes people treat it as the interval scale, but theoretically it is the ordinal variable. So here the ordinal variable means ranking. We rank the questions in a logical order. For example, in a class of 100 students, so the rank holder one, the student who obtained 80%, the rank is one. The second student who obtained 72%, rank two, and the third student 68%, rank three. So it's a logical order, and the student one is more intelligent than student number 2 and 3, and the student number 3 less intelligent than the student number the 1 and 2 who obtained the rank 1 and 2. So here we use the statistics equal, does not equal, less than, and greater than. So here we do not use the term plus and minus. We cannot say the rank holder one 2% more intelligent than the second student. So here we do not use plus and minus. We simply say it's a ranking. The one rank holder one more intelligent the others. Okay, and we take the median. The third type question we can prepare for our research, that is interval scale. Interval scale, basically the equal interval on the variable represent equal differences in the property being. The example, the difference between the 6 and 8 is equivalent to the difference between 13 and 15. So it's a 0 to 20. The difference between 6 and 8, what is the difference? Difference is 2. And the difference is 13 and 15. again difference is 2. So it's a equal difference. So how to prepare question for interval scale? Now it's an example of interval scale. You can see here the how likely, it's a simply statement or it may be in the form of question also. How likely is it that you recommend this company to friend or colleagues? So we can prepare our interval scale type question like not likely to very likely, and the 0, 1, 2, 3, it's a 11 point scale, and we can use here plus and minus also, and we find mean and standard deviation. So mean and standard deviation cannot be find for ordinal and in a nominal scale data. We can find mean and standard deviation for interval and ratio scale type data. And the fourth question, that is fourth, we can prepare our question in an interval scale. So in an interval, sorry, ratio scale. So it's an example of ratio scale. The ratio scale means it start from 0. It's a 0, like the age example of ratio scale. But sometimes researcher categorize the age like the 20 to 30 years, 30 to 40 years. When we convert age into in a different slabs, then it's a nominal type question. Okay, then we treat it as nominal, not ratio. When we are giving the actual age of the respondent, then it is the case of a ratio variable. And here, like the age of 45 and the age of another person 90, so we can say the 90 years age person 2 times of 45. So here we can use multiplication and division property also, or we can say the 45 age half of the 90. Okay, so we can use division also, plus and minus also. So maximum statistical tool and technique can be used for the data interval and ratio scale. So we should prepare maximum question 70-80% in a metric data and some question in a non-metric also. But we should not prepare all the questions in a nominal scale type question. So we cannot, if we prepare all the questions in a nominal scale, like a mutually exclusive question where two or more categories, then we cannot use many statistical tool and technique. Only we can use chi-square test. Okay. Now there are three types of analysis. One is univariate technique, bivariate technique, and multivariate technique. Now question is which particular statistical tool and technique we should use. It is only depend on the type of data or type of question we prepared. So we can prepare four types of question, or I should say we prepare two types of question. One is metric data or metric question, and another is non-metric. Non-metric means my question either interval or ordinal, and metric means my question either the interval or ratio scale question. Here nominal and ordinal question, non-metric. Okay. So we have large number of statistical tools and techniques such as one sample t-test, independent t-test, pair t-test, ANOVA, NCOVA, MANOVA, MENCOVA, repeated measures ANOVA, Wilcox-Con rank sign test, Friedman ANOVA, Kruskal-Wallis test, and Mann-Whitney U test, chi-square test, multiple regression analysis, discriminant analysis, logistic regression, factor analysis, cluster analysis, conjoint analysis, multidimensional scaling, correspondence analysis, mediation, moderation, structural equation modeling, and we have large number of statistical tools and technique. But the question is which particular statistical tool and technique we should use. So it is depend on the type of data, which type of questions we prepared. If we prepare all the questions in a nominal scale, so we cannot use all these techniques. We can use only chi-square test. So before, if we want to use the structural equation modeling in our research paper, then what type of question we should prepare for structural equation modeling? So it is very important to understand the type of data, whether my question in a metric form or non-metric. So there are three techniques. Univariate means when we are analyzing only single variable. Okay, so it's a univariate. Bivariate means two variables, and multivariate means more than two variables. So all the statistical tool and technique depend on the two types of variable. One is dependent variable, and another is IV, means independent variable. Okay, so we should check whether my dependent variable in metric form or non-metric, because my statistical tool and technique depend on the type of question we prepared. So if my question metric, then we can use the technique that is known as one sample t-test. Now I am talking about here univariate technique. In a univariate technique, the dependent variable dv, if it is non-metric, then I can use one sample median test. Okay, if my question in an ordinal form, then I can use one sample median test, or one sample will Coxcon rank signed test. Okay, but if my dependent variable in a metric form, means my question in a metric form, I prepared my question either interval or ratio scale, then I can use one sample t-test. Same as the other technique, like a bivariate technique. In a bivariate technique, there are two types of variables. Though the one is bivariate means two variables. The one is dependent variable and another is independent variable. So there are two possibility, whether dependent variable, it may be metric or another non-metric. Independent variable, again there may be two possibility, it may metric or it may non-metric data, non-metric question. Now I take the first case when dv, it's a dependent variable dv, and independent variable means iv. Okay, there are two variable. So we y means dependent variable, notation of dependent variable y, and independent variable x. If my dependent variable the y, it is metric form, this metric, my question in a metric, and independent variable also metric. So example of the sales y, that is sales is a ratio scale question, and the x means advertising expenses. If we have two variables, dependent and independent variable, both in metric form, then we can use the bivariate regression analysis or simple regression analysis. So it means we can predict sales on the basis of advertising expenses, and both the variables should be metric form, means both the questions should be in a metric form. Then we can apply simple bivariate regression analysis. It means whatever statistical tool and technique we are using, it depend on the type of questions we prepared. If my question sales that is metric data, dependent variable, and it is non-metric like independent variable, then I cannot use this technique. The condition of simple regression analysis is both the variable in should be in a metric form. Okay, and the second condition, the y, that is dependent variable, the dependent variable, it is in the form of metric, and x, the independent variable, non-metric means categorical variable. There are two category, like male or female. Okay, and metric means salary. So I can develop the hypothesis here. The hypothesis, there are two types of hypothesis. One is null hypothesis and another is alternate hypothesis. Null hypothesis, we assume that there is no significant difference between male and female teachers in a private sector, means the salary getting by male and female teachers in a private sector. Alternate hypothesis says there is a significant difference between salary getting by male and female teachers. So for hypothesis testing purpose, if my independent variable iv independent variable two categories, then we use independent t test. Okay, independent t test. So the condition of independent t test, they only there are two category. If the categories of independent variable, like the this x, more than two categories, if we want to know the salary on the basis of the education background, like science teachers, arts teachers and commerce teachers. Okay, is it any significant difference between getting salary by science teacher, arts teachers or commerce teacher? Now here we are comparing more than two categories, then we use analysis of variance. Okay, so the condition of analysis of variance is one dependent variable should be metric and independent variable should be non-metric or nominal scale type question, and it should have more than two categories, means three, four or five. So and the third case, the in a bivariate, the y that is non-metric, the dependent variable the non-metric and independent variable non-metric, then we can use the chi-square test. If both the questions mutually exclusive yes or no form and liked and disliked, then we can use only the chi-square test. And the fourth condition, that is the dependent variable categorical, means non-metric, and independent variable metric, means dependent variable non-metric, there are two categories, and independent variable metric, then we use discriminant analysis. The third type of analysis technique, that is the multivariate technique. Multivariate technique again can be divided into two parts. One is dependence technique and another is interdependence technique. Dependence technique, the multivariate technique, that is dependence technique. There are two types of multivariate technique. One is dependence technique and another is interdependence technique. So what is the difference between the two? In a multivariate technique means when we analyze more than two variables at a time. The variables may be three or four. Now, the what is the difference between the dependence and interdependence technique? So, the dependence technique, there are many dependence technique you can see here. The multiple regression analysis, discriminant analysis, logistic regression, MANOVA, conjoint analysis, canonical and structural equation modeling. So the dependence technique, like multiple regression analysis, the dependent variable y and the intercept b1 x1 plus b2 x2 plus b3 x3 and so on, it's a error term. Okay, so in a multiple regression analysis, all the variables, means all the questions, whether it is a dependent variable or independent variable, all the questions should be in a metric form. It means we should prepare all the questions in either interval or ratio scale question, then we can apply the multiple regression analysis. And one more thing, in a dependence technique, we can test the hypothesis also and find the relationship between the dependent and independent variable, like this. Here x1, the y, I am taking example y as a sales. Sales depend on the advertising expenses and the sales promotion. Another independent variable, sales promotion. And third, availability of the product. And there are many independent variables influence the dependent variable sales. So here we can uh, find the relationship between the dependent and independent variable. and as well as we can frame the hypothesis also, like alternate hypothesis, null hypothesis and alternate hypothesis. It means there are two variable, the y, that is sales, and x, advertising expenses. So there is a positive correlation. As we increase the advertising expenses, sales also increase. So here we can frame the hypothesis if there is no significant difference, or there is no relation between the sales and advertising expenses. But alternate hypothesis says there is a strong relationship between sales and advertising expenses. So in a in dependence technique, the purpose of dependence technique to find the relationship between independent and dependent variable, and as well as we test the hypothesis. So the multiple regression analysis, the all the variables the should be dependent and independent variable in metric form. Now the second condition, if the my independent variables in a metric form like this, metric form, all the questions in a metric, my questions either interval or ratio scale, and why it has a nominal scale, or it has two categories, then we use the discriminant analysis. Okay, so the purpose of dependence technique to find the relationship between the two variable and as well as testing the hypothesis. So now the structural equation modeling, basically it's a dependence technique. We find the relationship between the exogenous and endogenous construct. So it's the dependence technique, while the other confirmatory factor analysis, it's a interdependence technique. Now the second multivariate technique, that is interdependence technique. So today I'm going to explain the exploratory factor analysis. So all the interdependence technique, we do not find the relationship between the two or more variables, or we don't test the hypothesis in all these techniques, whether it is exploratory factor analysis, cluster analysis, confirmatory factor analysis, multidimensional or correspond analysis. We do not frame any hypothesis for exploratory or all the interdependence technique. The purpose of interdependence technique different from the dependence technique. We do not find a relationship between exogenous and endogenous variable, or a dependent or independent variable. We do not find any relationship between the between or among the variables. So like the exploratory factor analysis, so what is the purpose of exploratory factor analysis? The purpose of exploratory factor analysis, the data reduction and summarization. What does it mean, summarization means we have large number of questions, like we are taking 50 questions in our research, for writing the research paper, and we have taken 50 questions from different research papers or literature review, and we want to apply the exploratory factor analysis. Then this factor analysis will reduce the relevant, it will reduce the large number of questions into few, like 20 questions, and the 20 question again they divide into the several factors like f1, f2, f3, f4, and each factor has 4 or 5 questions. The total number of questions 20. So the for example, in the factor 1, 5 questions, 1 to 5 question in the factor, and question number 6 to 9, 4 question, and 6 questions, and the 4 questions or 5 questions. Okay, 4 or 5 questions. So in a factor analysis, it reduce the large number of question into few, and then we club same type of question into one, and we give the name. Summarization means giving the name. So it's the idea of the univariate, bivariate and multivariate technique. Now I am